Department of School Education, Warangal Urban, presenting digital lessons. Welcome to the Physical Sciences online class. Myself, Devulapalli Kiran Kumar, SA Physical Sciences, Government High School, Matwada, Warangal. In 9th class, Unit 1, Matter Around Us, today we are going to learn about: can matter change its state? What is matter made up of? How small are the particles of matter? There exists space between particles, and particles of matter attract each other, and observing the force of attraction between the particles of matter. Can matter change its state? Let us see. We know water exists in 3 states, that is, solid state ice cubes, liquid state water, and gaseous state. Many other materials that can exist in different states. Example, coconut oil is usually liquid, but on cooling it becomes solid. Camphor is a solid, but if you leave it in the open air from some time, it directly changes to gas. And we know naphthalene balls placed in cloths disappear after some time, but the smell remains. Why this happens? This is because the balls have changed from solid to gaseous state. Why this all happening? Why are properties of same matter different in different states? Think, children. When does water change into ice and then into vapor? Why do gases diffuse faster than solids or liquids? To answer these questions, we need to know what is physical nature of the matter and what is matter made up of. Let us going to know about what is matter made up of. All the matter is made up of very teeny particles. This looks as a simple statement, but it is very difficult to explain and understand about matter. See. For this, we need more details about the particles and their arrangement inside various forms of matter. Let us do some activities to know information about how small are the particles and how the space exists between particles and how particles inside the matter attract each other. See, children, let us do one activity for how small are the particles of matter. Activity 7. To do this activity, we need the following material. What are the material? We need 5 beakers, potassium permanganate crystals, measuring jar, spatula, stirrer. Let us see the procedure once. Take a beaker with water and add 1 or 2 crystals or few crystals of potassium permanganate and dissolve in water. What color do we observe? Let us see in the experiment. Let us do this activity. See, children, here taking 5 glass beakers. For 4 glass beakers with 90 ml of water, and in the first beaker we have to take 100 ml of water. In that there is a stirrer. Add few crystals of potassium permanganate and stir it well. What do you observe here? We observe a thick pink color in the first beaker. Now take a syringe. We are taking syringe as a measuring jar here. You have to pour exactly 10 ml of liquid from the first beaker. See here, taking 10 ml of liquid and transferring it into this second beaker. It is having exactly 90 ml of water. If you add it, it becomes 100 ml of solution. Observe the color of the second beaker liquid. It is also pink color. Stir it well. And again transfer 10 ml of liquid with the help of the syringe into the third beaker, which is containing 90 ml of water. Observe the color. Here the intensity of the color is changed. Now take 10 ml of the third beaker liquid with the help of syringe. Transfer it into fourth beaker. And observe the color of the fourth beaker also. It changes its color intensity. Now transfer finally a 10 ml of liquid of fourth beaker into the final beaker with the help of the same syringe. Observe the color. Is the water in the last beaker still colored? And how it is possible for a few crystals of potassium permanganate to color a large volume of water? Look once. There are color changing intensities from first to fifth beaker. What do you understand from this activity? Conclusions of the activity. We can do this activity with copper sulfate also. There must be several tiny particles in just one crystal of potassium permanganate which are uniformly distributed in water to change its color. And so we can conclude that both solids and liquids are made up of tiny particles. How do particles of the solids distribute in the liquid? Let us see. Let us find out it by doing the next activity, that is activity 5. Activity 8. There exists space between particles. To do this activity, we need the following material: a graduated beaker, salt, spatula and stirrer. Take water in the beaker and mark its level, and see here crystals of salt. Taking in another beaker, there is a stirrer in the beaker also. What happens after adding that salt into the water? Observe closely. After adding salt, using stirrer, stir well. The salt dissolving. Add some salt and stir it thoroughly with the glass rod and observe the level of the water. Is there any change in the level of the water? No. Very good. Add more salt and stir with glass rod. Observe the change in the level of water. Does the level of water change? And where did the salt go? The activity, we can conclude that liquid particles in a liquid have some space between them, and the solid particles enter into the space between the liquid particles on dissolving solid in liquid. By the intrinsic activity, once we can conclude that gas is also made up of particles and they have large space between them. And next, particles of matter attract each other. Let us see this with an activity. Activity 9. Observing the force of attraction between the particles of matter. To do this activity, we need the following apparatus: water tap stream, iron nail, hammer, and a piece of chalk. Let us do water stream activity. Open a water tap and allow the water to reach the ground. Like this. Now try to break the stream of water with your finger. Can you break the stream permanently or momentarily? Yes. Momentarily we can break, but not permanently. Are you able to break the stream of water anywhere from the tap to ground? What is the reason behind this stream of water remaining together? Now try to break a piece of iron nail with a hammer. See the activity. Take an iron nail, strong nail. Check the strength of the nail. Is it breaking with hands? No. Now try to hammering on the nail. Are you able to do it? Are you able to break the nail? Now take a piece of chalk. Try to break it with your hand. Are you able to do it? Yes. Can you rejoin? Break it into parts. Can you rejoin it? You can crush it with the help of a hammer. But we can't rejoin it. Conclusions of the activity. From the above observations, we can conclude that particles of the matter have forces acting between them that keeps the particles together, and is also clear that this force is not equally strong and different in different forms of matter. How diffusion takes place. Based on the several activities to explain diffusion of particles of solids, liquids and gases, it can be possible only when the particles of matter move continuously. Particles of solids, liquids and gases can be diffused into liquids and gases. Rate of diffusion of gases is higher than the liquids, while the rate of diffusion of liquids is higher than the solids. Reasons for higher rate of diffusion of gases. Number 1 is due to the higher speed of gas particles, and number 2 due to greater space between them. See the picture. Reasons for higher rate of diffusion of liquids compared to solids. We know liquids are having more diffused than solids. Particles in liquids move freely and have greater space between them when compared to particles of solids. That's why liquids diffuse faster than the solids. See the picture. Solids have the particles tightly and liquids have the particles freely movable. In a gas, particles are not as close together as in a liquid. If a colored gas is mixed with a colorless gas, the color spreads evenly in it. This happens faster in gas than in liquid because of large gaps between the particles of gas. Fewer particles of gas obstruct in the way of spreading. Let us see diffusion of bromine. Bromine is a brownish colored gas, hence its diffusion in colorless air can be seen clearly. If we allow bromine to diffuse in vacuum, it diffuses faster in vacuum because there are no particles to obstruct in its way. See the diffusion of bromine in air. Now let us see the homework for today's class. Children, write the answers for the questions given here. First question, which chemical substance used in tiny particle size experiment? Where did the salt particles go when we dissolve salt in water? Write about the space between the particles of solids, liquids and gases. Write the reasons for higher rate of diffusion of gases. And finally, make a model to explain the structure of particles in solids, liquids and gases. That's all today. See you in the next class.